Let's tackle find the duplicate number, which we want to try and solve with minimum complexities of O(n) time and O(1) space. We're given an array of integers called nums, and that contains n plus 1 integers, where each integer is in the range 1 through n exclusive. There's only one repeated number within nums, and we need to return this. It's required to solve this problem without modifying the array and using only constant extra space, making the O(1) memory requirement an absolute essential. You have 4 possible methods to try and solve this. They are A. Count sort, B. Floyd's hash set, C. Binary search, or D. Floyd's tortoise and hare. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who were able to get it, congratulations. And for those of you who just want to see some code, the answer is D. Floyd's tortoise and hare. The brute force approach is quite simplistic. Indeed, we can just use nested loops to solve this. It would be quite easy to iterate through using nested loops and find that repeated number, but the time complexity would be O(n) squared. So let's look at a more efficient approach that will solve this in O(n). Here we can see that we're using Floyd's tortoise and hare algorithm to find the duplicate number within our array. Let's give an overview first of how this is working, and then we'll go through a line by line. First of all, we're initializing 2 variables, tortoise and hare, to the first element in the nums array. Then we're using a do-while loop to move the tortoise and hare pointers through the array. As you can see, our tortoise is moving 1 step at a time, while the hare is jumping forward 2 steps. We continue this process until the tortoise and hare pointers meet at the same element, which is where tortoise equals hare. That would indicate the presence of the cycle in the array. Once that happens, we're going to reset tortoise to the first element in the array, and then use a while loop. This can be used to advance both the tortoise and hare pointers 1 step at a time until they meet again. That is, when the tortoise equals the hare. The meeting point is guaranteed to be the duplicate number, and we can just return it, which will be hare here. Or tortoise, either one of them will work. In any case, I'm going to go through this line by line just to make sure there's a full understanding. So once again, we initialize tortoise and hare variables to the first element in the array. Then we use the do-while loop to move the tortoise and hare pointers through the array until they meet at the same element. We then move the tortoise 1 step at a time and the hare 2 steps at a time in each iteration of that loop. And obviously when we find that meeting point, we will be resetting the tortoise after we've exited that do-while loop. We reset it to the first element in the array, and then we're going to use a while loop to advance both tortoise and hare pointers 1 step at a time until they meet again. So within this, we move the tortoise 1 step and the hare 1 step at a time in each iteration of the loop. After that's done, we return our duplicate number, which is either that hare or tortoise variable. So, I hope that that's clear, and if not, I strongly recommend checking out the more visual solution offered in the Udemy course in the description to this video. Dr. Ibrahim is a much better teacher than I am, and I think he offers quite a few similar problems as well within the same lecture. As for our applications purposes, just remember that to solve find the duplicate number, which is quite an easy problem, we can use Floyd's tortoise and hare. There's quite a lengthy explanation as to why here, and if you prefer learning from just reading code, you can do so in C++, Python, or Java as well. Just going to make sure that this Python is correct. Okay, looks good to me. So that's everything. We're going to be continuing with a slightly more complex problem next. We're moving on in the Coding Card Sharp learning mode to merge k-sorted lists. Thank you very much again.